Introduction to Machine Learning. Definition: subset of AI enabling systems to learn from data. Learns patterns and makes decisions without explicit programming. Core components of ML. Data foundation of ML. Features: measurable inputs. Model: mathematical representation. Training: learning from data. Loss function: measures prediction error. Optimization: improves accuracy, example, gradient descent. Types of machine learning. Supervised learning uses labeled data. Examples: linear regression, SVM. Unsupervised learning uses unlabeled data. Examples: k-means, PCA. Semi-supervised learning, mix of labeled and unlabeled. Reinforcement learning, learning through rewards and penalties. ML workflow. Define problem, collect data, clean and preprocess, feature engineering, select model. Train model, evaluate performance, deploy model and monitor and maintain. Popular ML algorithms. Linear regression, supervised, predict continuous values. Logistic regression, supervised, classification. K-means, unsupervised, clustering. SVM, supervised, binary classification. Random forest, supervised, complex decision tasks. Neural networks, supervised, deep pattern recognition. Tools and frameworks. Languages: Python, R, Julia. Libraries: scikit-learn, TensorFlow, PyTorch, Keras. Platforms: Google Colab, AWS SageMaker, Azure ML. Real-world applications. Healthcare, diagnosis, imaging. Finance, fraud detection, trading. Retail, recommendations, demand forecasting. Autonomous vehicles, perception, planning. NLP, chatbots, sentiment analysis. Advanced ML concepts. Deep learning, CNN, RNN. Transfer learning. Generative models, GANs. Explainable AI. Federated learning. AutoML. ML challenges. Data quality. Overfitting, underfitting. Bias and fairness. Interpretability. Scalability. Security, adversarial attacks. Conclusion. ML is transforming industries. Requires good data and thoughtful model design. Continuous learning and improvement. Thank you. Questions and answers.